in chemistry of carbon compound, we are now focusing on functional groups. Let me clarify more that in previous lecture we discussed about hydrocarbons. You are aware that hydrocarbon, that is the compound made up of only hydrogen and carbon. Now, apart from hydrogen and carbon, other compounds, other elements are also there. Say for example oxygen, nitrogen, like that various elements, even halogens. Halogens means bromine, chlorine, fluorine, iodine. All these group 7A or 17 number group periodic table, they are considered as halogens. Halos means sea salt, generated from sea salt, therefore they are having name as halogen. Now these halogens are also there, and like that compounds are there. So we have to discuss now functional group. Now first part, that what is functional group? Because of that particular arrangement of atoms, certain characteristics are there for chemical compound, and therefore they are considered as functional one. Let me clarify again. You are aware of alkane, the first member of alkane, that is methane. So it is CH4. This is alkane, or we are calling this as methane. Now I am removing one hydrogen from here. You are aware that carbon is having 4 bonds. Here carbon is having 3 bonds. So one more bond is remaining, because there was also hydrogen. We removed that. So whatever this group or a sort of radical is produced, we are calling this as methyl. So CH3 we are calling as methyl. So here we have suffix, that is YL. C2H6, you are aware it is ethane. But I am removing one hydrogen from this side. So C2H5, and one bond is remaining, because here also hydrogen was there, but that is removed. Then this is called as ethyl. The parent one was ethane. We are calling this as ethyl. So in short, alkane is there. We are removing out ANE. As one hydrogen is less, we are removing out this ANE, and we are adding out here suffix as YL. This is called as alkyl group, and it is denoted by letter R. So R and this type of bond, we are calling this as alkyl group. This is the first we have to discuss. The important functional group, we are denoting this by alkyl. So same way, you are aware, this is benzene ring, that is aromatic compound, where all these carbon atoms are attached to hydrogen atoms. So formula of this benzene, that is C6H6. Now as in case of alkyl group, we remove one hydrogen, so we are removing one hydrogen from this side. So as one hydrogen is removed, this becomes C6H5 and having site open. So here any atom we can attach which is favorable. Then this is actually aromatic compound. So this is called as aryl group. So we are calling this as aryl group. So this is here aryl group. We are simply denoting this group as AR and dash. When I am denoting this way, we have to understand this is aryl group, aromatic group. So we have to take this down, all these functional group, and then we are going to discuss other functional groups. So here only hydrocarbon functional group we discussed. Now we are adding other atoms to it. Now we are discussing the group with OH. When we are talking about inorganic chemistry, in case of inorganic chemistry, many times students are having concept in mind that OH means basic or alkaline substance. It is not true. Let me clarify here the concept. This is M, O and H bond. You are aware about electronegativity. Otherwise, observe our periodic table lecture. There we discuss about electronegativity concept. Here I am just revising definition. Electronegativity is tendency of an atom to acquire electron cloud in bonding condition. So whenever two atoms are in bonding condition, they tries to attract electron cloud more towards itself. This tendency is called as electronegativity. In periodic table, I hope you must have periodic table in front of you physically or mentally. Electronegativity decreases as we move down the group and electronegativity increases as we move across the period. Across the period means from left to right and down the group this way. So when we move down the group, electronegativity decreases. When we move across the period, electronegativity increases. And that's why you'll find that oxygen, fluorine, nitrogen, these elements are having more electronegativity. Fluorine is showing highest electronegativity in periodic table. Now, oxygen is having high electronegativity as compared to hydrogen. So, obvious thing is that oxygen will try to pull electron cloud towards itself because oxygen is more electronegative, hydrogen is less electronegative. Now, question is that what is this M? Don't consider M is metal. Any atom or atomic group, whatever that atom or atomic group, we have to consider total electronegativity of M. If electronegativity of M is greater than electronegativity of hydrogen, then obviously the electron cloud will be pulled this way, that oxygen will pull and this will oxygen will pull electron cloud from M also. But as M is more electronegative, the O and M bond will be stronger and both will pull electron cloud from hydrogen to greater extent. And therefore, ultimately M releases out. So M will come out losing electron over there. So we will get this MO, whatever that, minus charge and H plus charge. According to Arrhenius concept, if substance releases H plus ion, then that is acidic one. And that's why whatever the M electronegativity is there, accordingly H will release. So if this M is more electronegative than hydrogen, then H plus ion will be released and the substance will behave like acidic. If electronegativity of M is less than H, then the situation is that this way actually, but oxygen and hydrogen both will pull electron cloud, releasing M plus and OH minus. If OH is liberated, you are aware according to Arrhenius, the substance is basic in nature. And therefore, metallic oxides, when dissolved in water, they are producing MOH. Metals, many metals are having less electronegativity than hydrogen. As we say that hydrogen is towards left side top. As we move down the group, electronegativity decreases and metals are having place down the hydrogen. And therefore, here the metallic oxides, when dissolved in water, they are releasing out OH minus and therefore they are basic in nature. So it is not necessary that by looking at OH, you should say OH is acidic or OH is basic. It depends upon what is the electronegativity of this atom or group of atoms. Whereas, just imagine if electronegativity of M and electronegativity of H is same, then neither H will release nor OH will release. Alright? And then we are getting the situation that is substance is neutral in nature. Getting idea? So substance may be acidic, may be basic, or may be neutral, depending upon this the condition. Now after discussing this, you are now sure that OH group is not only basic. We are calling this OH group as hydroxyl group. So hydroxyl group is not necessarily basic. It depends upon what type of atom or group of atoms are attached. So let us check out first AROH. Sorry, not AROH first. We are discussing first ROH only. So if I am talking of ROH, R stands for alkyl group. Let me clarify here. It is CH3OH or C2H5OH. Then this group is called as alcohol. This is called as alcohol. So ROH group is alcohol. This is according to IUPSC. We have to give name as this way. The parent compound here, that was methane. No doubt group is methyl, but parent compound is methane. So I have to remove this E and I have to add here on OL. So this is called as methanol. Now you can name this way. This is ethane. So name ethane, but don't write E at end and name on. So this is the IUPSC nomenclature, that is International Union of Pure and Applied Chemistry. According to that, this is the nomenclature, but old nomenclature, or we are calling that as traditional name, are commonly used. Say for example, this group is methyl and this group is called as here alcohol. So we are calling this as methyl alcohol. This group is ethyl. So we are calling this as ethyl alcohol. Whenever a person is said to be consuming liquor, the major component of liquor, that is influenceable component, that is C2H5OH, that is ethyl alcohol. But ethyl alcohol is not only used in liquor. Apart from that, in medicines, they have important uses. Ethyl alcohol is very good solvent, and its bad point in case of liquor, that it is having very high absorptive power. The moment person consumes liquor, it reach out till brain within just 2 minutes. This is high diffusion power of alcohol that is utilized in medicine also. That's why medicines are having small amount of alcohol, not all. Certain medicines, they have small amount of alcohol, and therefore substance, that medicinal part is dissolved in alcohol, and therefore it can reach very easily in the blood. So basic idea of use of alcohol is that. If you are considering that only allopathic medicines are having alcohol, the answer is no. Ayurvedic medicines are also having good amount of alcohol. If you check out certain category, they are called as Asav category. In Ayurvedic medicine, it is written that self-generated alcohol is not more than %. Sometimes even 12% or 12 point something percent also reports are there. Now, this is used in medicine. Then another important thing, it is very good solvent, and therefore in organic chemistry, various solvents are used. Out of that, the important solvent we are using here, that is ethyl alcohol. Aldehydes and all that chemicals are also made by using ethyl alcohol. In chemical reactions, it is playing very important role. When we are talking of poisonous liquor, that sometimes it is contaminated with methanol. Methanol is poisonous. Ethanol is not poisonous. No, ethanol is also poisonous, but level of poison decreases as carbon number increases. So C3 component will have comparatively less poisonous thing. Anyway, so here we are discussing about this. This is ethyl alcohol or alcoholic groups. So if I am talking of ROH, we have to consider it as alcohol. Now we are discussing another group. Here we we are saying this way that R already is there, it is attached to C. Okay, but this C is attached to only O here, and then it is attached to OH also. Now oxygen is having more electronegativity as we discussed. Now consider this entire part as M. In previous example there was only R. R is made up of only carbon and hydrogen. Carbon and hydrogen are having compatible electronegativity, and therefore alcohols are neutral. But now this component is not acting as neutral component. Why? Because oxygen here is being more electronegative. It will try to pull out electron cloud from carbon to oxygen. As a result, carbon will try to pull more electron from oxygen towards itself. And then obviously if I am considering this entire as M, then electronegativity of M will be definitely greater than electronegativity of H. And as a result, it will release out H plus ion. And you are aware, if H plus ion is released, then we are calling that substance as acid. So this group is called as carboxylic acid group. So carboxylic acid group, simply I am writing here, we are showing this way, R C double bond OH. Then this is called as carboxylic acid. First group we discussed, that was ROH, that is alcoholic group. Now RC double bond OH. Say this is O and this is O. This is structurally I have shown, but writing straight way we can write this way. So this is alcoholic group, then this is acidic group. Now another compound giving OH group we have to discuss. This is AROH. Now you are aware, AR means what? Benzene ring, which is having one bond vacant. All other valencies are satisfied by hydrogen, but this bond is vacant, and we are attaching here OH. Again same thing, that no doubt this ring is made up of carbon and hydrogen only, but still here the resonating effect is there, and because of resonance this group is having little bit more electronegativity than electronegativity of hydrogen. As a result, this group is also tend to release H plus ion, but not as easily as in case of carboxylic acid. Alright, but little bit, and therefore these are called as very weak acid. So this is called as phenolic group. This compound is called as phenol. So when these type of compounds are there, we are calling them as phenolic group. So third component we discussed, that is AROH, that is phenolic group. Now in chemistry we discussed particularly previous lecture that structural formula is something different and chemical formula is something different. Now we are talking about not directly OH group, but compound involve both O and H. Let me clarify. It is R, C, you are aware this is double bond O. Till that it is alright, but here I am mentioning H. Instead of OH we have written H. But if you are writing a formula, you may write this way, and you will feel that OH group is present. And to avoid this confusion, this compound is written as RCHO in this fashion. This compound is written. This is called as aldehyde. So it is RCHO. We are calling this compound as aldehyde. Having almost similar thing, little bit different thing here. So that is aldehyde. Alcohol is converted into aldehyde in human body. keep in mind a person, if person is having alcohol in body, it is not bad, or alcohol is not actually poisonous. In our body, that alcohol is converted with some enzymes, that alcohol is converted into aldehyde. So as you are aware that ethyl alcohol is converted into ethyl aldehyde, that is called as ethanol, or traditional name acetaldehyde. So ethyl alcohol is converted into acetaldehyde. Acetaldehyde is having poisonous impact. Same way, methyl alcohol is converted into methanol. Here aldehydes are written by prefix, say for example ethane, and we are writing Al at end. In case of alcohol we are writing Ol, and in case of aldehyde we are writing Al. So ethyl alcohol or ethanol is converted into ethanol. Methyl alcohol is converted into methanol, or traditional name is called as formaldehyde. Say acid, as we discuss here, that CH3 COOH. This acid being 2 carbon atom, we are calling this as acetic acid. Now this acetic acid is present in vinegar. You are aware of vinegar. So it is acetic acid. 4% dilute solution of acetic acid we are calling as vinegar. So which is acid. From that acid also this aldehyde is obtained. So we are calling this as acetaldehyde. Same way here this is acidic. Now formic acid, we are calling this as, I am removing this CH3 by H, but other things are same, COOH. Then this is called as formic acid. Formica in Greek language means red ant. The acid obtained from red ant, that's why it is called as formic acid. The aldehyde obtained from this is called as formaldehyde. So traditional name of methanol is formaldehyde. Formaldehyde is highly poisonous in nature. And now you are aware that formaldehyde is obtained from methyl alcohol. And that's why if liquor is having small amount of methanol, that is methyl alcohol, then it is poisonous, because in our body methyl alcohol is converted into formaldehyde, which is deadly poisonous. When we are considering that poisonity of formic acid, formaldehyde, we have to consider this way, that when we are saying formalin solution, you are aware that in biology laboratory various specimens, that animal or plant, they are preserved in some liquid. That liquid is formalin, which is consisting of 50% formaldehyde and 50% water. It is so poisonous that all these scavengers, that means microorganisms, are not able to even survive in that climate, and then we can preserve that animal or plant, whatever that specimen, that is for longer time, and for that purpose formaldehyde is used. Now here we have discussed this about some of the functional group we are discussing here. The next functional group I supposed to discuss, that is ketone. Now you are aware that R, C, double bond O and H, this group we call as aldehyde. Now I am replacing this H here and I am adding here R, but intentionally writing out a dash over there. So this is called as R dash. So R, C, double bond O, R dash. This type of group is called as ketone. So this is called as ketonic group. So here we are having a suffix as O-N-E. The well-known ketone for you that we are using, we means actually girls are using in day-to-day life, that is nail paint remover, that is called as acetone. So acetone belonging to this category. Acetone is very good solvent, and not only nail paint but various other inks or ball pen ink even can be removed with help of acetone. So this is actually acetone, ketone. Now ketonic group is considered in aldehyde group as well as ketonic group togetherly. Many times we are considering aldehydes and ketones. This is represented as RC, R dash and O. But proper representation of this group is this. Now these ketones are having use in organic chemistry to greater extent. They are good solvents and precursors. Precursors means from that we can produce some different chemicals, and so they are used in organic chemistry to wide extent. Out of that, one example we discussed, that is acetone. Now next functional group I should say here, that is R. Here I am saying O, and again R dash. Everywhere we have to consider R may be equal to R dash or R may not be equal to R dash. In previous example also, ketone example, R and R dash may be same or may not be same. Here R and R dash may be same or may not be same. This group is called as ether. Don't mix out this ether with physics. In physics also we are saying that why transverse waves are traveling in vacuum. It is said that some hypothetical medium is there that is called as luminescence ether. But that is not here what we are talking of, this ether. So ether is highly inflammable substance over here, highly reactive, highly inflammable substance. We are calling that as ether. So I am discussing about this functional group and somewhat about detail. So this is RO R dash. We are calling this as ether. If R and R dash are same or may not be same. Now next group is similar to acidic group. This is RC double bond O O, and you are aware in acidic group we written here H, but now I am writing here R dash. This group is called as ester. So here I am writing this group as this way, R C double bond O O R dash. So ether is having O and connected to R and R dash, whereas ester is having one R dash and other side RC double bond O, that is connected here. Now this is called as ester. Esters are widely used in artificial fragrances and flavors. So when we are talking of various artificial essence, fragrance, all these things, because esters are having fruity smell, fruity odor is there for esters, and therefore they are widely used in artificial fragrances, flavors and all that. So this is example of ester. Till here we discussed that every compound, functional group, with respect to presence of oxygen. Now I have to introduce here another substance which is nitrogen based substance basically. You are aware this NH3, this is called as ammonia. Ammonia is something this way, that nitrogen and 3 hydrogen atoms are attached. This is just representation. Actual diagram is not like that. Even when I am talking of methane, then don't consider that all bonds are in perpendicular direction. Just representation is there. Now here I am removing one hydrogen from amine. If one hydrogen is removed from amine group, then whatever the substance is there, we are calling this as amine. So from ammonia, substance derived that we are calling as amine. And therefore, NH2 group we are considering as amine group or amino group. So here we have now next group I have to introduce here, that is amino group RNH2. This group is called as amino group. So here I am adding a group here, that is amine, NH2. You are aware that here there is no presence of oxygen, but still amines are basic in nature. So when I am talking of amine, you have to keep in mind that concept that this is having basic nature. Next element we have to introduce here, that is X. There is no element, as symbol is X, but we are representing halogens under heading X. So they are called as halides. So here I am talking of this compound Rx, they are called as halides. Now different halides are there. So for example, if RCl, we are calling this as chloride. It is not necessarily only RCl, it may be RC. Here H and Cl. May be possible, I am removing this H and I am adding here also Cl. So it is dihalide. May be possible, third, tetrahalide, trihalide, sorry, and so on. So different halide compounds are available. Out of that, the important halide, I should say here, you are familiar with this halide. This is CHCl3. You must have heard about chloroform. So this is formula for chloroform, which was used in earlier days to surgery or all that. The patient will become unconscious by use of this. But now it is not used for that purpose. But in various chemical tests, you must have used this chloroform. That chloroform layer test and all that. So these type of compounds are there. We are calling them as Rx, that is halides. So this is list of some of the functional group. I am not saying this is all functional group, but prominent functional group I have discussed in this part. For rest of thing you have to go through textbooks, notes, and then we are getting this idea. Now, as per our discussion in previous lecture, that I am going to conduct a test. So here, after this lecture, you have to appear for test. So question paper will be in front of you, solve it, and then observe analysis part immediately. I hope you must have solved this paper. We are discussing now first CTFS, that is consider the following statement. Keys are there in front of you. So I am not discussing whether option A is right or B is right like that. I am just giving statement whether it is true or false. The ability to form long chain compound by carbon, that is called as catenation power. This is true. So mark there as true. Ethyl alcohol is more poisonous than methyl alcohol. Statement is wrong because we are aware that alcohol is not poisonous. In our body, alcohol is converted into aldehydes and aldehydes are poisonous. But still, if you want to take it as poisonous, then methyl alcohol is more poisonous than ethyl alcohol. So second statement is anyway false. So first is true, second is false. Give key accordingly. Chloroform, second question, chloroform is having formula CH3Cl. It is little bit changed, it is CHCl3 and therefore statement is false. When we are talking of CH3Cl, it is called as methyl chloride, whereas CHCl3 is chloroform. Biological specimens, second statement, biological specimens are preserved in liquid, that is called as acetic acid. No, it is called as formalin. Formalin is mixture of formaldehyde and water, 50-50%. And therefore, we are calling this statement as false statement. So both statements here are false. Amines, next statement, amines are basic in nature. That is true. As we discussed that NH2 group is basic in nature here. Ketones, second statement, ketones are used as flavors and fragrances. So the answer is actually esters are used as fragrances and flavors. So ketones are not used as flavors here directly. So answer is that statement is false. So three statements we discuss about CTFS. Then match the column. This is all question I have written here already. That match the column. You can check out that this group is acidic group. So I should match 1 with A. So acid, therefore it is B. So I should go 1 with B. The second one, that is ether. So second statement 2, that is A. The third, that is halide or chloride. So here halide is present. So third is going with C. So 1B, 2A, 3C, check out, it is in B. And so right answer here, that is B. That is 1B, 2A and 3C. And filling the blank, that cyclopentane is an example of dash dash. Options, just looking at all these options you can find out that all three options are open chain, and we are aware that as prefix is cyclo, it is not open chain. If prefix is cyclo, then it is obviously closed chain compound, and therefore here the answer is D, that is none of these. As usual, check out if three options are correct, three answers are correct, or more than three answers are correct, then all right. If less than three answers are correct, you have to observe this video lecture again and solve this paper again.